Hi, okay, welcome to lesson 3 on unit 2. It talks about reflections. So we've been dealing with translations up and down, right and left, and now we're going to look at reflections. Now to reflect, we are actually just changing signs of the y and of the x. Anyway, this lesson starts off with talking about invariant points. Invariant points are points on the graph which do not move after a transformation. They'll remain in the same position. So we're going to compare the graphs of y equals f of x and y equals negative f of x. What's really happening is the y values, which were f of x, are becoming negative because of this sign here. So let's take a look at that. The graph of y equals f of x is x squared minus 10x plus 25 as shown. And here it is right here, top one. Write an equation which represents negative f of x. So basically all we're doing is we're changing all the signs of f of x. This whole thing is multiplied by negative 1 in other words, because what we've done is we've taken this, multiplied it by negative 1. So here we are, you can see what's been happening, and so the signs all change. Now what does that look like? Using a graphing calculator you can sketch it. This is what it would look like. State the coordinates of any invariant points. Well, you'll find it's just this point right here at 5, 0. Why is it not moved? Because when we took the negative value of this point, really we've just changed the sign of the y value. Well, what is the y value here? It's 0. So it remains at 0. We haven't affected the x value at all here. All we're doing is affecting the y value, which is equal to f of x. Change the sign of the y value, not the x. So this point stays where it is, simply because when you multiply a coordinate or a value of 0 by negative 1, this guy here, nothing happens. So let me just scroll down. Okay, the next part here, it's showing you the graph of y, or f of x, equal to x cubed minus 8. So that's this one here. It's going like this. And again, we'll look at the negative of f of x. So what happens? It changes from here to here. And basically you might begin to see that what's happening is there's actually a reflection going on. This arrow here goes over here. This part of the curve ends up over here. It's actually a reflection in the x-axis. So that's what they're getting at right here. So the same thing occurs as an invariant point at 2, 0. Simply by multiplying the equation, the original equation, by negative 1, because that's what's happening, we get this equation. Now what are we doing? We're just changing the sign of the y value and going from positive f of x to negative f of x. So in changing the sign of the y value, at this point here with a coordinate of 2, 0, nothing will change. That's it here. So it's a reflection in the x-axis. It's the same with the one above, if you'll have a look. Part 3, graph of y equals f of x is shown. Sketch the graph of negative f of x. So just based on the fact that the graph is going like this, we don't even need an equation. We can just take some points such as this, perhaps this one here, one down here, one down here, and reflect in the x-axis. These, of course, will be invariant points. If they're reflecting the x-axis, they don't move. This one goes down here, and these go up, like so. So in other words, if we replace y with negative y, then y equals f of x becomes negative y equals f of x, or it's basically equivalent to what we've been looking at. So the replacement terminology is y goes to negative y. Next page, the graph of y equals x squared minus 10x plus 25 is shown. It's this one here on the right. Write an equation which represents y equals f of negative x. Now look what you're doing. We are changing the x, sign of the x, from positive x to negative x. That means all the x values will change sign. Now when you think about it, a point, say, such as this one here, 2, 3, will have the x coordinate changed to negative 2, 3. It's a reflection, in fact, in the y-axis. So if we change the sign of the x, it's a reflection in the y-axis. If we change the sign of the y, it's a reflection in the x-axis. Well, what happens when we change the x value? We have to put a negative x in here and negative x in here. So doing that, this doesn't really matter because it's squared, so it equals that. But negative 10 times negative x is positive 10x and the 25. Now if you sketch that with your graphing calculator, you'll get this graph on the left. Any invariant points? Well, the only invariant point would be a point on the y-axis. We haven't actually shown any here, but if we had a point like this at 0, 8, 0 would not change, even though you change the sign of the x. Negative 1 times 0 is 0, so it would stay the same. So for an example, on your calculator you can probably see that the graphs come and cross at 0, 25. That would be the invariant point. The graph of y equals x cubed minus 8 is shown. I'll just scroll down so we can see all of that. Okay, so here's the graph. Let me just clear the screen. And the equation, if we change the value of x, this will become negative x cubed. And negative x cubed would remain negative. It's just like if we have negative 2 and we cube it, it's really negative 8. So we still get negative. It'd be like, so what they're really doing here is they're cubing the negative 1 and they're cubing x. So negative 1 cubed and x cubed still gives negative x cubed. So that's what's happening here. So what's the graph we get? Well, the parabola looks like this. The original parabola, where are we here? Would have this graph actually starts here and goes all the way down with a little twist and down here. So this is also y equals f of x. This one here, as it goes down this way, is y, the other end of y equals negative x, f of x, sorry. Okay, so you can sketch that with a graphing calculator and see what it looks like. State the coordinates of any invariant points. Now we'll notice that this one doesn't seem to move. Again, this point's on the y-axis, and it's a reflection in the y-axis. This goes over here, and this goes over here. So this will be the invariant point. Any points on the y-axis won't move, and it's a reflection in the y-axis. So when we come to sketching the graph of y equals f of negative x, if you're given y equals f of x, it's quite straightforward. We're going to reflect points in the y-axis. So here are some points, and we can simply reflect, and of course this one here crosses the y-axis. We should see that as an invariant point. So we move that over there. This one comes all the way over to here, and this one will reflect over to here. And where does this land? This lands over here, and this lands over here. Okay, hopefully you follow that. Okay, comparing the graphs of y equals f of x and y equals f of negative 1 of x. Or if we just switch the x and y, we get the inverse. So we're going to compare the original graph with the inverse graph. So the graph of y equals x minus 5 squared is shown. That's the parabola. And if we reflect in this line, we'll get the inverse. So this one here is the inverse. Write an equation which represents x equals f of y, the inverse in other words. So let's take our equation and taking this, we'll switch the x and y's like this. So what do we get? The x and y's get shifted in the equation. We have to square root both sides. We're square rooting a variable like y. So we have to, our answer should be plus or minus square root of x equals y minus 5. So this will not be a function when we solve for it because it's parabola on its side. Using a graphing calculator, we can sketch this now. We can actually graph this and sketch it here. Now we can see what invariant points, we're getting ahead of ourselves here I'm sure, but you can see if it's a reflection here in the x equals y line, any point that crosses that line will remain on that line. So these are invariant points here and here. So what else is there? There's 1, 2, ends up here and here. Okay. Although there are 4 points of intersection of the graphs, explain why there are only 2 invariant points. Well, the original graph only crosses once, twice. Okay, a little bit further down the page, we are looking at a graph of y cubed minus 8. It's this one here. And again, if we reflect it or take the inverse, it's going to reflect in the x equals y line. And we'll get this graph here. Now, if we're writing an equation for that, we switch the x and y's, and we won't go into the detail, but we'll get the following. Notice with a cubic function, when we take the root, we don't need a plus or negative because it doesn't matter whether this is positive. It doesn't matter whether the y is positive or negative. You can take a cube root of, or an odd root of a positive or negative number. Use your calculator and you can check this out. And mark the invariant points. Well, that's that one right here. How does the graph compare? How do the two graphs compare? Well, it's a reflection in the line y equals x. And again, if you look at this and examine this, we can see that if this is the original graph from here to here, by the looks of it, and what's happening here, I'm trying to see the original graph, it's kind of a strange. Here is part of it. Hard to see what's going on. Oh, yeah, I guess the original graph is this one here. Sorry, all the way down like that. And of course it gets reflected and we end up with sorry, 1 second. If I change colors, we'll get this graph here, the red. Okay. So, replacement terminology. So if we do the inverse, as we know already, the x and the y changes and the y and the x swaps positions also. So I'm not going to talk very much here. I want you to, it's just to read this over on the video and see the blanks that need filled in. It'll make sense now that we've gone through that lesson. So I'm just going to scroll down. You can pause this if you need to write anything down. So here's the third row of data to be filled in here. Makes a note at the bottom of the page. Given the function y equals f of x, replacing x with negative x describes a reflection in the y-axis. So that's what's happening. So this describes a reflection in the y-axis. If you've gone from y equals f of x to y equals f of negative x, reflection in the y-axis. Replacing y with negative y describes a reflection in the x-axis. So this function also has gone from here to negative y f of x, or you can write it as y equals negative f of x. Reflection in the x-axis. Interchanging x and y, as we know, like this, describes a reflection in the line y equals x. And we can use the inverse notation for the function. So those are the three functions, or three reflections rather, we are interested in. Okay, in these examples in your book, you can see that the graph of f of x is shown, and this shows you what the graph of negative f of x would look like. Here, again, this is now showing you what it would look like if you change the x to negative x, y equals f of negative x, and what happens to the original graph. Original graph looks like this one here, along here. And then the third one, I'll scroll down. Okay, so here you've taken the inverse, so we get a reflection in the line y equals x here. So I'll have a look at that. Last example 2, the graph drawn in the thick line is a reflection of the graph drawn in the thin line. Write an equation for each graph drawn in the thick line. So this is f of x originally. So this thick line is simply, looks like it's been reflected in x equals y, y equals x, so it's just simply the inverse function. So that's what the function would now become. This one's been reflected in the y-axis, so x has been replaced with negative x. This has been reflected not in the y, but in the x-axis, because this point here has gone up here, this point has gone down here. So y, a reflection in the x-axis, all the y's become negative. If the y's were negative, they become positive. So here y's are negative and they're becoming positive. Here the y's are positive, they're becoming negative. So they're all changing sign. So here in combining reflections, we can do more than one thing at a time. Obviously, we can do two reflections. We can go from y equals positive f of positive x to y equals negative f of negative x. It just means there'll be a reflection in the y and the x. So reflection in the x-axis will change y to negative y, and a reflection in the y-axis changes x to negative x. So your equation would change originally. If you're doing just a reflection in the x, you're changing the sign of the y. In other words, you get this, or I prefer to write it like this. And now if you go ahead and do a reflection on top of that in the y-axis, you're going to change the x value. So this is going to become negative. So this is what we get when we do a reflection in the y-axis. So what's going on? It looks like a reflection in the x. So this is the original, gets reflected in the x, then gets reflected in the y. So you're going from here to here, and then from here to here. Okay. Transformations in the table are applied to shape A in the order shown, and specifically that order. And I think if you change the order, it wouldn't matter. This would go over here, and then it would be reflected down here. Order does matter in some situations when we're doing all these transformations. We'll get to that later. Alright, so in this part here, it says complete the table below to determine the equation which results from changing the order in which the reflections are carried out. You can see if we do change the order, as I mentioned above, that we do end up with the same, exactly the same equation. Does the order in which the reflections are carried out affect the final image? No. Describe two sets of transformations in order which can be applied to the original graph, y equals f of x, to produce the graph of this. Well, simply reflection in the x followed by a reflection in the y, or you can do it reflection in the y followed by the reflection in the x-axis. Okay, moving right along, we have transforming this to this and this. Alright, transforming. In each case, complete the table and sketch the combination of transformations on the grid. So I'm just going to shorten this video up, I'm just going to let you read what's going on here. This is just replacement technology for reflection in y. That would become the equation, followed by a reflection in the y equals x line. So normally what happens there is x goes to y, y goes to x. So if you're dealing with this, we're going to have to swap these two. Now careful, this becomes x, so here we have it here. Negative, nothing happens, so that just goes there. And x turns into y. So this is slightly different. So be careful with what's happening here. This doesn't turn into y, it turns into negative y. Because negative to negative, x to y. So here's the diagram. If you look at A, the first thing that happens is it goes to 1, and then reflection in the y equals x line goes to 2. Replacement, again here, reflection, first of all, in the y equals x, in other words, it's an inverse function. You switch the x and y's, you get this. Fair enough. Now a reflection in the y. What happens? If you reflect in the y, the x's become negative. X changes sign, so here, our x is going to change sign. This stays the same. You can bring the negative over to the other side. If you multiply both sides by -1, you'll get this. And again, this is the original. Reflection changes to this one, followed by a reflection in the y going over here.